Who needs a little more time? Take a little more time. You sure can. All right. Let's go through the types of reactions first, because you should be able to recognize them just from the reactants. What is number 1?
No reaction. No reaction.
It's no reaction, that's for sure. And it is also, if it, well, actually, you don't even have to give it a type because it is no reaction. Okay, so we say, what type would it be if it were to react? It would be a single replacement, okay, but it's no reaction, so we can just cross that out. All right, so we don't have to do anything with that one. So I don't know why I moved this down. Whoops. Let's move that up again. All right, number 2, what type of reaction is number 2?
Decomposition.
It is decomposition. How do you know that? There's just one thing there, right? One compound. So when you are predicting the products of a decomposition reaction, what do you do with the 2 elements? You separate them. So you write Ca, and then you write O, and then you have to check and see if the formulas are correct. Almost everything has no subscript, but there are 7 plus 2 is 9 exceptions. Okay, so calcium doesn't have a subscript, neither does iron or carbon or, I was going to say linoleum, but that's not an element, that's a flooring, rubidium, tin, lead. None of those have any subscripts. Who are the ones that have subscripts? Tell your partner right now, who are the elements that have subscripts? You need to know this cold. You can't be thinking about it anymore. We've done it in about like 2 or 3 units now. So it is Brinkelhoff. Whoops. Or you can just look at your periodic table and know where they are on the periodic table. And then there are 2 others which I will always give to you, but you need to know to look for them. Who are the ones that I will give to you? Anyone know? I'll give you S8 and I will give you P4. So there are 9 of them that have subscripts. All the other elements, no subscripts. So we're going to put a 2 here. Once you have those, you may not touch the formulas anymore. Don't touch the formulas. Don't touch the formulas. Can I change this to a 3? No, because I cannot change the formulas. Can I change this to a 6? No, because I'm not allowed to change the formulas. Once you've written the formulas, and don't worry about balancing, because you don't balance by writing the formulas. You just write the correct formula. Now you balance using, what do we use to balance? Coefficients. So I'm going to put those in red, okay? So coefficients are going to go in red. So once you've written the black stuff, you may not touch it. Black you have to leave alone. You can only put numbers in front. So you don't have to use a chart, but I'm going to, just because I know some people really like it. Okay, I have C, A, and O are my two elements. All right. And on the right-hand side, I have 1 and 1. On the left-hand side. On the right-hand side, I have 1 and 2. How can I fix that with coefficients? I can put a 2 in front of the CAO, which changes both the CA and the O. And now I need to fix the calcium by putting a 2 in front. Excellent. Whoops. Whoops. Sorry, I'm just trying to move this thing down. There we go. Why will it not move? There we go. Okay. N2 plus SR, what type of reaction is that? That is synthesis. So I'm going back to black to predict our products. I'm going to give you some choices here. And you can tell me if you like A, B, C, D, or E, none of the above. Do we like A, B, C, D, or E, none of the above? Tell your partner. E, none of the above. Why is that? Because we need to make sure when we put two elements together, they're always going to be ionic. Okay, I won't have you predicting covalent compounds. They're too difficult to predict. You'll always be predicting an ionic compound. And you need to put your metal first. And you need to figure out what the charge is. What is the charge on strontium? It is in group 2. 2 plus. What is the charge on nitrogen? 3 minus. And just in case you have forgotten how to write a formula, you need the total positive to equal to the total negative, which means you need to have 3 SRs, so SR3, and 2 Ns, N2. You have now written the correct formula. Are you allowed to change any of the black writing? No. So we're now going to use red for our coefficients. I'll give you a hint. If you have an element that has no subscript, do that one last because it's going to be the easiest to balance. Okay, so do strontium last. Okay? Oh, except for, guess what? Not much to do here, is there? So we have N, and we have SR, we have SN, and we have SR. We have 2 Ns, we have 2 Ns, we have 1 SR, and we have 3 SR. Where do we need to balance? The SR, we need to put a 3. I made these really far too easy on the balancing front, but that's okay. Okay. Next, what do we have? Question number 4 is what type? Yes, of course. Question number 4 is, everybody, what's question number 4? Single replacement. I'm going to give you some choices as to the products. I'm not going to put subscripts on them, but you'll get the general idea, okay? Now, barring the fact that we understand that the subscripts are incorrect, which of these, A, B, C, or D, at least shows the right elements in the right order for the compound? Do we like A, B, C, or D for the compound that's going to be formed? D, because we have our metal first, and our non-metal is coming in and replacing the other non-metal. The fluorine is kicking out the bromine. The bromine is going to be on its own. So we're going to have ALF, except it won't be ALF. Should it be ALF too? Why not? Because Al is 3+ and F is negative, so we need to have 3 fluorides to balance the charge of the 3+. So that's going to be ALF 3. Can I touch the black writing? No. Now that I've got my correct formula, I do not touch the black writing. Oh, have I finished? I got so excited I forgot to put the element. How did I get 3 on the fluorine? I need to have 3. The aluminum has a 3 positive charge. You good now? Okay, cool. Who is my other element? Br. And then you have to ask yourself, does that element need a subscript? Is it one of the 9 that needs subscripts? Yes, it needs a 2. So now once we are there, don't touch the black writing. Now you can only add coefficients. So we have Al, Br, and F, Al, Br, and F. On the left-hand side, there's 1 aluminum. On the right-hand side, 1 aluminum. Left-hand side, 3 bromine. Right-hand side, 2 bromine. Left-hand side, 2 fluorine. Right-hand side, 3 fluorine. I have an odd number and an even number of bromines. Likewise, I have an odd number and an even number of fluorines. What do we do when we have odd and even numbers? We find the lowest common multiple and aim for that number. So the LCM is 6. How can I get 6 bromine on the left? How am I going to get 6 bromine on the left? Multiply by 2. Now we have 6 bromine. All right. I'm going to worry about aluminum last. Hopefully it'll just sort itself out. I need to have 6 bromine on the right. How do I do that? I put a 3 here. That will give me 6 bromine. Now bromine's good. Fluorine. I have 2 fluorine on the right. How many should I have? 3 times 2 is 6. How many fluorine do I need on the right-hand side? I need 6, so I'll put a 2 here, and that gives me 6. And now my aluminum, I don't have 1 anymore, I have 2, and I have 2. Is good? Okay. Excellent. SrCO3 plus K. What type is it? Single replacement. Who is K going to replace? It's going to replace Sr. So K is going to get together with CO3. K is positive, CO3 is 2 minus. What is the correct formula for potassium with carbonate? K2 CO3. We need 2 positive Ks to balance out that -2 on the carbonate. Who gets kicked out and is all by itself? SR. Does SR need a subscript? Is it one of the 9 elements? No. So we do not want a subscript with our SR. Balancing, remember you're going to balance CO3 as a group. Okay, so we have SR, CO3, and K. We have SR, CO3, and K. We have 1K, 2K, 1 CO3, 1 CO3, and 1 SR, 1 SR, and oh look, all we need to do is put a 2 there and we're done. Okay, so the balancing on these was pretty straightforward. Sometimes you'll get more difficult ones than that, but that's what it's going to be like, but we're going to add in those extra 3 reaction types, okay, before you do your quiz on this. Okay, so your quiz would be like this, but with the extra 3 reaction types. And we're going to learn the 4th one in our list today. So let us go to, let's see, synthesis. Using the solubility table, page 66. Actually, go to page 67 and have your blue sheet out. Okay? No. This one is just here in case you didn't have your blue sheet with you and you needed a copy. Okay? Here are a few words that you need to know. Soluble means that a compound will dissolve in water. If it will dissolve in water, it is therefore aqueous, AQ. So if you go back to page 66, and we look at this, our cations are listed in the middle column. Our anions are listed on the left column. If you have any of the alkali ions, which are listed here, lithium, sodium, potassium, cesium, rubidium, francium, and you pair that with any anion at all, it will be soluble. What does soluble mean? Dissolved in water, which means that the state is going to be AQ, aqueous. So if I gave you lithium nitrate, soluble, aqueous. If I gave you potassium chloride, aqueous. If I gave you sodium phosphate, aqueous. Okay? This is only if you're doing reactions in water. Like obviously if I say, you are given some salt, and I don't say anything about water, or I don't say solution, then salts are solids, unless you've actually put them in water. So if there's no water, will it be aqueous? Never. But this is saying if there's water around, will this thing stay as a solid or will it dissolve? Okay? So there are other things that are also soluble with everything. Those ones are the hydrogen ion and the ammonium ion. Those are soluble with everything. So they will also be aqueous. So if you have ammonium hydroxide, ammonium chloride, ammonium iodide, ammonium phosphate, ammonium sulfate, ammonium sulfite, ammonium perchlorate, they will all be soluble. They will all be aqueous in solution. We also have some anions that are always soluble with everything, and those are NO3- nitrate and CH3COO- acetate. So it doesn't matter what positive ion you put with nitrate, it will be soluble. So you can have calcium nitrate, iron nitrate, tin nitrate, iridium nitrate, neptunium nitrate. Any nitrate will be soluble. In other words, it will be aqueous. Now we finally get down to the slightly more interesting ones, okay? So if you have chloride and you pair it up with silver or lead or copper 1, and this is copper 1, not copper 2, okay? If you have mercury 1 or mercury 2, it is low solubility. What does that mean? It means that if I have silver chloride, AgCl, and I put it in water, it'll just sit there and not dissolve. Okay? Throw it in, stir it around, like, oh, well, that did nothing. You'll just have solid sitting there. Okay? Does not dissolve. So low solubility means it's going to be a solid, means it's going to be S. But if you have anything else that's not in this list here, if it's not in that list and it's with chloride, it will be soluble. So if I have, is calcium in our list? No. So if I have calcium chloride, it will be soluble, it will be aqueous. If I have iron, is iron in that list? No. And it's not just chloride, it's also bromide and iodide. So if I have iron bromide, solid or aqueous? Aqueous. Okay? And you can see this works all the way down. If you have sulfate, there is a list of things that it is solid with. And then everything else, if you pair it off with any other ion, it is aqueous. Sulfide, we have a list of a whole bunch of things that it is soluble with. It's soluble with H, NH4, all the alkalis, which you should know already because those are the ones that are listed as being soluble with everything. Beryllium, magnesium, calcium, strontium, barium, those are the only ones which are soluble with sulfide. So if I said calcium sulfide, is that going to be solid or aqueous? Calcium sulfide. Everybody. Or sorry, sulfide, not sulfate. What am I doing? Oh, calcium sulfide. Aqueous. What if I said lead sulfide?
Solid.
It's not in that purple list, therefore it will be low solubility, so it will be solid. Okay, and it works the same way for the rest of them. All right, I'm not going to list everything here, but we're going to go on to our next page and use the table. So low solubility means it will not dissolve in water and it is a solid. So let us predict the state. See if you can do it without actually looking at the answer. Maybe cover it up with that piece of paper or your periodic table or something, and see if you can predict the state of barium sulfate. Barium sulfate. So look on your blue sheet. And you'll look up sulfate, which is on the left-hand side, SO4, 2 minus. Is it going to be solid or aqueous? Solid, okay, and we've got it here. Just to confirm that, I've taken out this part of the table. If you look up sulfate and you say, what is it like with barium? That is low solubility, and so it will be a solid. So BaSO4, solid. Now I would like you to try AlOH3. So go look up the OH. You're normally going to start with your anion. Look up your anion on the left. Solid or aqueous? Solid. Okay, because hydroxide, if we had it with, we look here and we say, where is aluminum? Do you see aluminum up here? No. That means that aluminum belongs in the all other category, which means that it is low solubility, which means it is a solid. Okay, CuCl2. I'm warning you, this one's tricky. Solid or aqueous? Aqueous. You meant aqueous. Now, it is meant to trick you. Copper is meant to trick you with chloride, okay? So we look up our anion, chloride, and then we look for copper. Now, the problem with copper is now you need to use your knowledge from Unit 4 to figure out what is the charge of copper here. You know that you have 2 chlorides. What's the total negative charge? -2. So what is the charge of copper? +2. And that means, is it this copper? No, because that's copper +1. Copper +2 is in the all others category. So it is soluble. Chloride, copper 2 is soluble, so therefore it would be aqueous. It can be very helpful, although not required, to memorize that all salts containing ammonium, acetate, and the alkali ions, so AAA, ammonium, acetate, and the alkali ions, and then an N, nitrate. They are always soluble. So if a salt contains any of those, it will be soluble. It's handy to memorize that. It is not required because it is given to you on the blue sheet, but it can make your life easier if you don't have to look that up, okay? So what you're going to do right now is you are going to write the state for all of these when they're placed in water. Okay, so take 5-10 minutes, we'll do that, and then we're going to move on to predicting products of double replacement. And if you are your last day, or if you have forgotten, don't forget that your phones are in your bags now. We're getting used to that for next year, okay? Plus, we don't have any time to waste. We are down to our last 13 and a half days before the end of school. So, nope, not even 13 and a half. 13.25 days. Okay? No. That's why we're moving. And we're going to test the last 2 units together. Yes. When you have a test, you get the sheet. You get the blue sheet on the test. They quiz at the test, you get the blue sheet. So what's the plan of you? Yes, so we go from man to time. English way. Yes, because I don't know. Yes. Any questions? Yes. Yeah. Yes.
Like try to figure out if it's aqueous or
Okay. So anytime it says soluble, those are aqueous. So far, so good. Anytime it says low solubility, that's a solid.
Okay.
So if I was to put chloride with silver, so if I had silver chloride, that would be a solid.
Okay.
If I had mercury with bromide, that would be a solid. But if I have anything other than these, those would be aqueous.
Paired with these
Paired with
ones?
those ones, yes.
So that's what this like okay.
Yeah.
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 Can I go to the bathroom?
Yeah, for sure. Okay, if you're finished that, we're going to be taking a look at a demonstration. So on your piece of paper, write out those as your reactants. And then you're going to predict, if I place those in water, are they going to be solid or are they going to be aqueous? Okay, so I'm going to put these in brackets here, solid or aqueous. Is lead nitrate solid or is lead nitrate aqueous? It is aqueous. It's one of the ones, nitrate, if you can remember that all nitrate salts are soluble, that will help you out. How about Ki? It contains an alkali, so it will be aqueous. Now what I'm going to do is I'm going to show you what these look like. All right, so we have some potassium iodide. Ooh, what does it look like? Looks like water, right? It is a clear, colorless liquid. That is because the ions break apart and what we have is we have K plus ions floating around and we have I minus ions floating around. I don't know if you remember back from the very first unit, the very first lab we did. Do you remember the solutions are clear? Light passes through them because the ions are all separate. They are so small that light passes right by them. It doesn't bounce off. Okay, you only see cloudiness if you have a particle big enough for light to bounce off. Okay, so these are aqueous. So these float around separately from one another. Okay, so they're just floating around willy-nilly all by themselves. There's thousands and millions and billions and trillions and quadrillions of them. Okay? Lead nitrate. Let us, oh, I need a test tube wrap, forgot that. Okay, so that was my potassium iodide, and here is my lead nitrate. Ooh, what does that look like? Looks like water. It is clear and it is colorless. Why is it clear? Tell your partner, why is it clear? The individual ions are too small to do what? They're too small to bounce light off of them. Okay? Individual ions too small to scatter light. Therefore, these are clear. Okay. Now, what kind of a reaction would you expect if we put these two chemicals together? A double replacement because we have a compound and a compound. Okay? I'm going to rewrite the reaction down below so that we can work with it. We have Pb, NO3, 2 aqueous plus Ki aqueous and I'm going to show you how to predict your products correctly. Okay? First thing you do is you write out who all the ions are. So, who is this ion? Pb. What is the charge of that Pb? And how do you know? NO3 is -1, and you have 2 of them. Okay, so we know that we have an NO3, which is -1, and we know that we have 2 of them, so that means that the lead has to be 2+. We also know that we have a K. What's the charge of K?
1.
1. And what's the charge of I? 1 negative. And what we're going to do now is we are going to combine our outside ions. I'm going to make this one big and long so I have room for my inside ions. These are my outside ions, and I go from left to right. So Pb comes first, and I comes second, which is as it should be. A metal should go before the non-metal. Cation goes before the anion. But doing outside ions helps you do that correctly, okay? So what is the formula that we get when we combine Pb2+ and I-? Pb2I? PbI2. PbI2. Okay, so that's one of our products. And then the next thing we're going to do is we are going to do our inside ions. And you'll notice I went from left to right for the outside ions. I go from right to left for the inside ions. That's going to put my positive ion first and my negative ion second. Okay? So what is the formula when we combine K first and NO3 second? KNO3 because they're just positive and negative. So I got KNO3. And what I would like you to do now is I would like you to figure out, are each of these solid or are they aqueous? So once again, are they solid or are they aqueous? PbI2. Oh, do I not have it here? Oh, it must be in here. What do you get for Pb and I? Solid or aqueous? Solid. And how about K and I? Aqueous. So we should get a solid here. Do you want to see the solid form? Okay, I'm going to stand up on the little step stool if I can find it. There it is. because that way you'll be able to see better because I'm so short. Now, you want to watch because if you miss it, if you blink, you'll miss it. It's a really fast reaction. Are you ready?
Yeah.
You'll miss it if you're not watching. 5, 4, 3, 2. Oh, really fast reaction, yes? So, how can you tell there's a solid in here? The light is reflected off. It is cloudy, so you know you have a solid. The light is bouncing off that solid, so you know that you have formed a solid. Who is this solid? PbI2. We call this solid a precipitate. We call this solid a precipitate. A precipitate is a solid that forms in a double replacement reaction. Okay? Is good? Okay. While we're here, is this a balanced chemical reaction? No, but double replacement are pretty easy to balance. Usually you won't end up with more than 2s or 3s, 4s or 5s at the outside. So we need to balance NO3 by putting a 2 here. We need to then balance K by putting a 2 here. And that takes care of the I, which also needed a 2. Are we good? Okay, back to wherever the heck it was. Nope, not here. Here we go. Okay, so question number 1, define the term precipitate. This is on page 69. That won't be difficult for you to remember. Define the term precipitate. We just did that. It shouldn't be too difficult. I'm not going to actually, you know what? These are going to be homework. So if you've finished it, then that's great. There will be more homework along with these two. We're not going to do this. We're going to do our own examples, okay? If you want an extra example, you can watch the video, okay? Now, oh dang, okay. This is sideways. So what I'm going to do, I forgot to make it right way around. I am going to print screen because I can do this with an image. I think I can do this. I think I can rotate an image. Rotate, yes. Rotate right. And it won't let me do it with this thing. See? No rotate. Stupid thing. Anyway, regardless, now let's make this thing bigger so we can see it. Oh, there we go. All right. So now we're on page 70. And we're going to take a look at what happens with all of our ions, okay? So you might have a situation. This right here is going to be clear and colorless. This is a solution. It is aqueous NaNO3. And what do you notice about all the ions? What are they doing? They're chilling. They're floating around freely. Okay, so maybe this one's moving around like this, and this one's moving around like that, and this one's moving around like this. They are all separate. Why is it clear? The ions are too small to scatter light. Okay, and the same thing is happening when I have K2S. So my first beaker contains sodium nitrate, Na. I have Na plus ions, NO3, I have NO3 minus ions. And remember, nitrate is soluble with everything. That's why it is dissolved, okay? K2S also separates into ions. And did you notice that the, come here. So frustrating. Did you notice that the Ks don't stay as K2? They each float around separately from each other? Okay. How many Ks are there in this beaker? How many Ks are in this beaker? Count them. There are 6 Ks. How many sulfur are in this beaker? 3 sulfurs. What's the ratio between those two? 3 to 1?
2 to 1.
2 to 1. Oh, look at that. K2S, a 2 to 1 ratio. Yes, that's why you have 2 potassiums for every 1 sulfur. And everybody's freely floating. La, 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 la. If we combine our outside, let's write down our ions. We have Na plus, we have NO3 minus. And if you're not writing down the ions, get with it. You have K plus and you have S2 minus. We're going to combine our outside ions. What do we get when we combine our outside ions?
NAS.
NAS?
Na2S.
Na2S. So those are our outside ions, give us Na2S. And then which direction do we go for our inside ions? Do we go left to right or right to left? Right to left. Our inside ions. What is the correct formula when I put K plus and NO3 minus together? KNO3. Now, what I'd like you to do is I would like you to look up KNO3 and tell me what is its state, and look up Na2S and tell me what is its state. KNO3, solid or aqueous? And this is where, if you memorize nitrate, nitrates are soluble with everything. Yeah? And how about Na2S? Aqueous, because Na is an alkali and alkalis are soluble with everything. So it turns out that our products are also aqueous. And if they are aqueous, that means the ions are floating around separately. So I would like you to tell me, taking a look at this little picture here, did we, from here and here to here, make any new substances? Did anything recombine in a different way?
No.
No, we had free-floating NAs and we still have free-floating NAs. We had free-floating NO3, we still have free-floating NO3. Free-floating K, free-floating K, free-floating S, free-floating S. Can you guess what you should actually write for this reaction? Reaction. No reaction. No new substance. All you did was mix it. It's like if you mix salt and pepper. Are there actually new substances, or is it just salt mixed with pepper? It's just salt mixed with pepper, and that's essentially what you're doing here. You're mixing them, but you're not getting anything new formed. Okay, so there's no new substance, so there is no reaction. How do you write that there's no reaction?
NR.
NR. Woo, that was exciting. If a precipitate does form, let's take a look at this one. We have sodium chloride aqueous. What that means is that we have separate free-floating ions. And this is also aqueous, so we have separate free-floating ions. Now remember, we're going to take our outside ions. Who are the outside ions? Na plus and NO3 minus. What do those make? Na, NO3. Na, NO3. Solid or aqueous? Aqueous. Shh. I know, we're in the last 5 minutes. You need to pay attention to this, okay? Is it going to be ClNa or NaCl when we do our inside ions? Or sorry, Ag. AgCl. Ag is plus. Cl is minus. Do I need any subscripts? Or is it just AgCl? Ag is positive 1, Cl is negative 1. What's the correct formula?
AgCl2.
Ag is positive 1, Cl is negative 1. So it's just AgCl. So we look at our products, and if you look them up, we're not going to spend time doing this right now because we have 5 minutes left. You're going to find that AgCl forms a solid and NaNO3 is Aqueous. What does that look like? Stop looking at each other and look at this. What's that down there? That's our solid. Is that a new substance?
Yes.
Yes. So did a reaction take place? Yes. What do we call that solid? That's called the precipitate. Okay? Now, there's one other situation you could have. You could have no precipitate, no reaction. You could have one of the products form a solid. What's the other situation you could have?
Solids.
You could have two solids. Let's take a look at the next page. Except for I need to make it sideways again. Control print screen. Grab that. Okay, here we go. Control V. Rotate right. 90 degrees. Make it bigger. Bigger, bigger, bigger. Bigger, 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 bigger. There we go. All right. Outside ions, copper and hydroxide. Inside ions, strontium and sulfate. What is the charge of copper here? 2+, because SO4 is 2-. Charge of hydroxide is -. If you cannot refrain from talking to each other, I'm going to ask you to get out in the hall and talk to each other there, please. Strontium 2+. Seriously, if you want to continue talking, then you can go talk in the hallway. We have 4 minutes left, 3 minutes, okay? Just hold it together for 3 minutes. Copper goes with hydroxide. Strontium goes with SO4. Cu2+ and OH- gives us CuOH. 2, if you look that up, that is a solid. Strontium goes with sulfate. They're both 2+, 2-, so we get SrSO4. If you look that one up, that one is solid. And so when you predict your products, you will get a precipitate and a precipitate. Do you have any free-floating ions anymore? No. So your homework is going to be, there's a bunch of other examples here if you want to look at them. Page 73. I really needed to get us to the end there so that you would know what you were doing for the homework. Thank you for your patience. I know I was kind of grouchy and directive and like, do this, do that. Thank you for putting up with me. K is an alkali.
Oh.
So if you look up sulfide, K is one of the alkali ions, so it's soluble. Yeah. Have a lovely Tuesday evening, everyone, and afternoon, and all of those things.
Vehicle license plate number PK179K and PT943N Please move your cars from the EV parking area. We have people that need to charge their vehicles.
I just spent live.
Leo, remind me when you're writing the test. Tomorrow. In more, okay. Can you please get ready? 15 Okay.
Oh, there will be different things.
What? I'm setting up. Yeah. Yeah.
Wesley, Cullen, please go to the career center. Wesley, Cullen, to the career center.
Bye.
I need somebody for my chemistry.
You didn't share.
No worries. Okay. Tomorrow's good?
Yeah.
You can try.
No, you're good. You'll just do it tomorrow. All good. No worries.
Got it. You're almost going.